Before sunrise, 1,000 thermometers wake across the land. Each one knows only its own corner of the world, and yet, somehow, from these scattered whispers, we draw a single, seamless sky. How? And how do we know the picture we draw is real? Here is the forecaster's oldest problem. You have readings, here, and here, and here, but nothing in between. To fill the gaps, you lean on an assumption so old it has a name, Tobler's first law. Everything is related to everything else, but near things, more than distant ones. A warm reading rarely sits alone, its neighbors lean warm too. The whole craft of the map rests on that lean, so let's measure it. Pick any station, and listen to the one beside it. More often than not they agree. Warm keeps company with warm, cool with cool. Step farther, and the agreement fades. Farther still, and it's gone. That fading echo has a shape, and a name. On a timeline, a value that resembles its own recent past is autocorrelated. The printer signal leaves on its own future. Here the echo isn't carried by time, it's carried by distance. Leave a value behind, walk in any direction, and for a while it follows you, fainter with every step. But next door is a decision, not a fact. Who counts as a neighbor? The 3 closest stations, everything within 50 miles. Every region that shares a border, each rule draws a different web across the land, and here is the uncomfortable truth. Change the web, and you can change the answer. The map doesn't hand you its neighborhoods, you choose them, so choose them out loud. Write the choice down as a grid, a 1 wherever 2 places are neighbors, a 0 everywhere else. That grid is the spatial weights, and to a computer scientist, it's simply an adjacency matrix, the skeleton of a network. Divide each row so the weights sum to 1, and something nice happens. Multiply this matrix by your data, and every place is replaced by the average of its neighbors. 1 matrix, 1 multiply, and the jagged map softens. A graph network would call that a message passed between neighbors. A photographer would just call it a blur. Now we have 2 numbers for every place, what it reads and what its neighborhood reads, on average. Pin one station, here's its value, here's its surroundings. Pin the next, and the next. Sweep the whole map, and you've gathered 1,000 little pairs. Each place, beside the company it keeps, there's a single picture that holds all of them at once. To draw it, we have to leave the map behind just for a moment. Lift every station off the map, give it 2 coordinates, how warm it is, left to right, how warm its neighborhood is, bottom to top. The geography falls away, and 1,000 places settle into one cloud. Now fit a single line through it. If the cloud leans uphill, warm keeping warm company, cool with cool, the line tilts up. If it's shapeless, the line lies flat. That slope is the whole story, compressed to 1 number. It even has a name. Moran's I, not a new idea, an old one in disguise. It is a correlation coefficient. It is the slope of a regression line. It is your variable, regressed against its own neighborhood. And there are only 3 skies it can describe. The first, weather as you know it. Warm pooled with warm, systems holding together. The line climbs, the number runs toward +1. The second is a sky that almost never forms on its own. Hot, cold, every neighbor a contradiction. The line falls, the number dives toward -1. And the third, pure noise, no systems, no pattern, every reading a stranger to the next. The line lies flat, and the number rests near 0, almost. +1, -1, or 0, that's the scale. But here's the catch the textbooks bury. Perfect randomness doesn't land at 0, it lands a hair below, at -1 over n-1, a faint repulsion baked into the arithmetic. So how do you know your map's tilt is real, and not a trick of small numbers? You cheat, honestly. Take your readings and shuffle them across the map, hundreds of times, measuring the slope each time. Those maps have no pattern by construction, they draw a bell curve of what nothing looks like. Drop your real number in. If it falls far out in the tail, the pattern is real. But a high number is not the end of the story, it's the start of a question. 2 maps can tilt exactly alike. On the first, a storm is truly spreading, each cell warming the next, real contagion. On the second, 2 regions glow for the same hidden reason, the same sun, the same latitude, touching nothing, influencing no one. Moran's eye cannot tell them apart. It sees that things cluster. It never sees why. Geographers call this trap Galton's problem, and the honest forecaster keeps it close. The statistic finds the pattern. You still have to find the cause. One number told us the sky has structure, but a forecaster needs to know where. So take that single slope and break it back apart, one small piece for every place, and let each piece fly home to its own coordinates. The map repaints itself. Deep warm islands, where heat keeps heat, the hot spots, cool pools that hold together, the cold spots, and threading between them, thin and sharp, the places that defy their neighbors, a warm cell marooned in the cold. Those lines have a name you already know. They're the fronts. The global number found the pattern. The local map shows you its anatomy. From scattered whispers, a single sky, measured, tested, and mapped, nearer things, related. Now you can prove it.